So what we have here is a simplified version of a hardware demonstration of tuned mass damper. So when we think about a tall building, and it has a huge mass, right? And it's a very stiff, so mass and spring system, second order system. But unfortunately, there's not much of damping. So simplification of that model is a underdamped second order system. So imagine that tall building, we hit by a strong wind, then it will shake a lot, discomforting and unsafe. And in order to damp out that energy, we attach a second mass, and we tune the natural frequency of the second mass to the first one, so that we can damp out that energy. So even if the tall building is hit by the wind, it doesn't move, but only the second mass moving damp out the energy. So that's why we have this one here. So basically we have a fourth order system here, and the original system has this mass, moving mass. It's a moving shaft here, and it's connected to this metal string here. So mass and spring.
Okay.
And something different about this system from the tall building is that this one is quite well damped system due to this voice coil actuator. But anyway, we have a mass, spring, damping here, second order system. And in order to suppress this natural frequency, we attach this second mass here, using this aluminum blade as a second spring. So basically, we have a fourth order system.
So that's basically the
it
spring
moves like
motion
this.
of the second mass.
Yes. So it moves like this. Okay.
And then, so what plays the role of the wind in this system? So this is the motion of the building, right?
Yes.
And where is the wind coming in?
So the wind is actually the force hitting the building, right? And the force is generated by this voice coil actuator. And so basically we command any input, force input, like sinusoidal or step input, through this controller here. And then controller sends out the force signal to this actuator through this power amplifier. And so we can force the building, and then we measure the movement of the building, movement of this forced mass using this LVDT sensor. And also this sensor output is also processed in this controller, so that we can see that output on screen of our computer.
Okay.
And additionally, so these are the air bearing blocks. So what we have here is a compressed air line. So the compressed air from the wall is connected to these air blocks. So basically this forced mass is kind of floating on the air, compressed air. So there's no mechanical contact, so no friction.
Okay. So no additional damping except for what is in here.
Exactly.